Hi everyone and welcome. Here is the Modbus I/O card from the Augmatic Technologies Private Limited, and they are the manufacturer of this card. Okay, and this card is specifically designed for analog output purpose. So in this video what we are going to do is we are going to control this card. Okay, we are going to control the analog output voltage of this card using Arduino. So as you can see, I have a linear potentiometer here which is connected to Arduino. Arduino is connected with this converter. It's a MX485 TTL to RS485 converter, and this converter is connected with this Modbus I/O card serially. As you can see, I have connected this two cable, okay, RS485A and B cable with this converter, and this converter is connected to Arduino. So whatever the reference I am providing from my potentiometer, that reference will come to Arduino, and Arduino will pass that value to this Modbus I/O card, and based on that reference this Modbus I/O card will set analog output voltage levels. Okay, and you can verify the analog output voltage reading on this DC voltmeter. So if I change the set point now, you can see the analog output voltage is changing. Okay, if I change more, it is not properly linear. Okay, so this potentiometer is not properly linear, so you will not see any linear communication. Okay, so that is why we have to travel this much to get only 1 volt. Okay, if I travel more, okay, you can see the voltage is increasing. So this potentiometer is providing the reference to this Arduino. This Arduino is sending those reference data to this Modbus I/O card, and based on those reference data this Modbus I/O card is changing the voltage level of this analog output 1 channel. Okay, and if I travel all the way to up, you can see 8.11 voltages. Okay, and if I travel all the way to down, you will see 0 voltages. Okay, so this potentiometer will provide the reference to Arduino. Arduino will convert those data into Modbus serial, or you can say Modbus RS485 protocol using this converter, and this converter will send those data to this Modbus I/O card over Modbus serial communication, okay, RS485 communication, and based on those data this analog output will vary. Okay, you can buy this converter online. You can buy this Modbus I/O card, okay, specifically designed for analog output purpose from Augmatic Technologies Private Limited website. Okay, so now let's see the connection. Okay, so here is the connection between our Arduino and this Modbus I/O card. So this Modbus I/O card is directly connected with this DC voltmeter. Okay, you can see this two cable. So this two cable is directly connected with this DC voltmeter. This potentiometer is directly connected with Arduino, as you can see here. So this potentiometer is directly connected with Arduino. Okay, and this converter is connected with this Modbus I/O card as well, and the Arduino as well. So what Arduino will do, Arduino will read the reference data from this potentiometer and send this data to this converter, and this converter will also send the data to this Modbus I/O card. Okay, and whatever reference Arduino will provide to this Modbus I/O card, based on that reference we can see the voltage levels on the DC voltmeter. Okay, or we can say this 7-segment display. Okay, now let's see the Arduino code. I will provide this connection diagram in the description of this video. Otherwise you can directly visit this link, okay, our GitHub repository link. You will get the code. Okay, and also I will provide this connection diagram in this folder. Okay, so I hope that makes sense. Okay, so let's see the code of Arduino. So here we have included the Modbus master library. So if you want to install the Modbus master library, just copy paste this thing, go to libraries and paste it here. Okay, you will see the Modbus master by Doc Walker. You can install this library and you can then after use this code. Okay, so we have imported the Modbus master library. We have defined the two function here, and we have to control the transmission of our data via this converter. So that is why we have to define some pins here, and we have to turn on and off these pins at certain time. Okay, so that is why I have defined this pin. We have defined the object of Modbus master. Okay, and then after this is my initial setup of Arduino. I have write the digital pin 8 as a high because this device needs power to turn on. Okay, so that is why I have turned the pin number 8 as a high, and I have connected the ground with this Arduino ground. Okay, and this is our pin mode of this pin which we have defined here. Okay, and then this is the two main part. Serial.begin is 9600 because Arduino will connect to this Modbus IO card serially with 9600 baud rate. Okay, and this device is having a slave ID of 1, so that is why I have specified the slave ID as 1. So if my device has a slave ID of 8, then I have to write 8 here instead of 1. Okay, but right now my device is having a slave ID of 1, so that is why I'm going to write this slave ID of 1. And here pre-transmission and post-transmission function I'm using. Okay, and then after these two lines are most important, void loop. So it will the void loop will run continuously, as you guys already know. Okay, so what my Arduino will do, my Arduino will read the reference from my potmeter at A0 pin number. You can see here the connection. So the output of this potmeter is connected to A0. Okay, you can see you can also tell the reference is connected to A0, and this is this two cable, okay, brown and the red. You can also see here brown and the red. So these two cables are power cables, like ground and 5 volt. Okay, so whenever I move or whenever I turn the port, okay, it will provide the reference to this Arduino, and whatever the value I am getting, okay, so float value is equal to analog read A0. So whatever my Arduino will read on the A0 pin, it will directly write to my 40,000 holding resistor. Okay, or you can say the first holding resistor of this device. Okay, so we already know that first holding resistor is associated with the analog output 1 channel. So whatever data this potentiometer will write to Arduino, that data will directly come to this Modbus IO card via this connector. Okay, and if this potmeter is giving 1023 value, okay, then this card will provide the maximum voltage. If this potmeter is giving the raw value of 0, this card will provide the 0 as the output voltage. Okay, so based on the reference of this potentiometer, the analog output voltage will be vary. Okay, so whatever reference you are setting from this potentiometer, as per that, this will provide the analog output voltage to the external world, and we are going to read, or we can display the analog output voltage in the DC voltmeter, or we can also use it for other purpose. Okay, so this is how it is all designed. Okay, now if you want to write the value to some other resistor, then you can just change it to, like, if you want to write to 40,001, then you can write just 1 here. Okay, it's a very simple. Okay, so if you are reading something on A1, okay, if you are reading some analog data to A1, and if you want to turn that analog data into the voltage levels, okay, then you can just add 2 lines here. Okay, so instead of 0, you can add just 2 lines. Okay, so you are reading the data from A1 and you are providing the value to 40,001 holding resistor. Okay, so this will read the data from your another analog input. Okay, so Arduino will read the data from another analog input, and it will provide the raw value to this Modbus IO card, and this Modbus IO card will convert that raw value into analog voltage levels on this analog output 2 channel. Okay, if you are providing here 40,001, then it is associated with the analog output 2 channel. If you are providing 40,000 here, then it is associated with the analog output 1 channel, so it will provide the analog output to this channel. Okay, as you can see, we are using 40,000, so we are accessing this analog output 1 channel, and based on our reference from this potentiometer, we can see the value on this DC voltmeter. Okay, so I hope this is clear to you. I will provide this code in the description of this video. Also, you can visit our GitHub repository to download this code. So I have already uploaded this code here. I will provide this link in the description of this video. Also, I will provide this diagram for your reference, that how you can connect your Modbus I/O card from Augmatic Technologies Private Limited with Arduino to operate the analog output voltage levels of this card using Arduino. Okay, so I hope this is clear to you, that how we can use this Modbus I/O card with Arduino to provide reference analog voltage to the external world. Okay, you can set the reference analog voltage of external world using potentiometer, or you can use any other sensor, and based on the sensor value, this Modbus I/O card will provide the voltage levels to the external world. Okay, so this is the very useful Modbus I/O card. You can integrate with Arduino, you can directly integrate with PLC, you can integrate with directly with a Node-RED, Ignition SCADA, or Raspberry Pi. Okay, so everything is possible. So this is the kind of masterpiece to use it in the industry, or use it in some small scale project where you are controlling the logic with Arduino and you are providing data to your external world with this I/O cards. Okay, so I hope this thing is clear to you, and this device and this Modbus I/O card is brought to you by the Augmatic Technologies Private Limited, and they are the manufacturer of this card. Okay, so if you want to buy this card, then you can visit their website. You can call on their salesperson number. They will also guide you. Okay, so I hope everything is clear to you, and if you still have any question or any doubt, then you can ping me on WhatsApp, Telegram, Instagram, anywhere, and we will see something more interesting in the future videos. So stay tuned for the future videos, and till then, take care, goodbye, and thank you.